Welcome to the lecture. I'm Dr. R. Venkatesan from Department of Mathematics, SRM Institute of Science and Technology. In this lecture, we are going to solve the problems based on inverse Laplace transform by partial fraction method. Splitting into partial fractions of the function s plus 2 divided by s into s plus 4 into s plus 9, we get a by s plus b by next factor s plus 4 plus c by next factor s plus 9. This is applicable if the numerator degree is less than the denominator degree, and in the denominator all are linear factors. If the numerator degree is more than the denominator degree, in that case first you divide by long division method, then we can move to this step. If the denominator factors are not linear, suppose any one is quadratic like ax square plus bs plus c, so for that factor alone, so it is of the form as plus b divided by as square plus bs plus c, plus for the linear factor you write as usual, so c by like ds plus e, so like that we have to do. Suppose any one factor is linear but order is more than one, like as plus b whole power some 3 is there, so for that factor, so a divided by without any power as plus b plus b by power 2 as plus b whole power 2 plus c by as plus b whole power 3, so like that it will keep on going. So here all are linear degree, so that's why we are written like a by one factor plus b by next factor plus c by next factor, like that. So simplify this RHS. So means the LCM of the denominators are s into s plus 4 into s plus 9. So now cross multiply. So a divided by s only there, but here s into s plus 4 into s plus 9. So remaining two factors are missing here. So s plus 4 into s plus 9. Similarly for the next one, so b here b divided by s plus 4 alone there. So s into s plus 9 plus c divided by s plus 9 is there. So s into s plus 4. Now compare these two factors. So denominators are equal, so numerator must be equal. So that means a into s plus 4 into s plus 9 plus b into s plus 9 plus c into s plus 4, which is equal to s plus 2. Okay. Now we need to find the values of a, b, c either by substituting the values for s or equating the coefficients. I'm going to find the values of a, b, c by substituting the values for s. First substitute s equal to 0. If you put s equal to 0, second term and third term will be vanished, then you will get the values of a. So what you may get? So a into 4 into 9. Okay, substitute s equal to 0 here, then you get this, which is equal to, so second term and third term will vanish. So in this RHS, so 0 plus 2, so 2. So now if you cancel, then you get a equal to 1 by 18. Similarly, put s equal to minus 4. If you put s equal to minus 4, then first term vanish, because this factor s plus 4 is there, for minus 4 plus 4 is 0. So first term vanish. So second term you get a value. So b into minus 4 into minus 4 plus 9 equal to, so third term will be vanished because here minus 4 plus 4 equal to 0, so third term will be 0. So here you get minus 4 plus 2. So if you simplify, which is equal to minus 2, so this 2 get cancelled, so you get 2 here. So b equal to 1 by 10. Okay, so b equal to 1 by 10 you may get. Similarly, put s equal to minus 9. If you put s equal to minus 9, so this factor will be 0, so first term will be 0, and in this, similarly in the second term also minus 9 plus 9, this factor will be 0, so this second term also 0, so third term you may get a value. So c into minus 9 into minus 9 plus 4, which is equal to minus 9 plus 2, that is minus 7. So from this c equal to, so here what you may get, so minus 9 into minus 5, so 45, so c equal to minus 7 by 45. So from this equation, so 1 you may get s plus 2 divided by s into s plus 4 into s plus 9 will become, a is 1 by 18, so 1 by 18 into 1 by s, plus b is 1 by 10, 1 by 10 into 1 by s plus 4, plus c is minus 7 by 45, minus 7 by 45 into 1 by s plus 9. Actually we want to find L inverse of s plus 2 divided by s into s plus 4 into s plus 9. So if you apply L inverse of s plus 2 divided by s into s plus 4 into s plus 9, you get L inverse of, if you apply L inverse on both sides, then you get this one by linearity property. So what is linearity property? Linearity property is this one. Linearity property, that is L inverse of a f of s plus b g of s will become a times L inverse of f of s plus p times L inverse of g of s. Okay, so this is the linearity property. That means we can bring the constant outside and we can split the terms. So if you apply linearity property here, so the 1 by 18 is constant, you can bring it out, so L inverse of 1 by s plus 1 by 10 is constant, you can bring it out, L inverse of 1 by s plus 4 minus 7 by 45, L inverse of 1 by s plus 9. This is by linearity property. Now use some basic inverse Laplace transform formulas. That is, Laplace transform of 1 is 1 by s. So L inverse of 1 by s is 1. Similarly, L of e power minus at is 1 by s plus a. L of e power minus at is 1 by s plus a. So this implies L inverse of 1 by s plus a is e power minus at. So here what you may get, so L inverse of 1 by s is there, so L inverse of 1 by s is 1, so 1 by 18 into 1, so 1 by 18 plus 1 by 10 into L inverse of 1 by s plus 4 is there, so L inverse of 1 by s plus a is e power minus 80, so a equal to 4 here, so e power minus 40 minus 7 by 45 into this is also in the same form. 1 by s plus 9 is the 1 by s plus a. L inverse of 1 by s plus a is e power minus 80. So e power minus 90. So this is the required inverse Laplace transform. So similarly, we will solve the next problem. That is, find L inverse of 5s plus 3 divided by s minus 1 into s square plus 2s plus 5. Here one factor is linear, another factor is quadratic. It is not reduced to linear factor. So these kinds of problems we have to, as we discussed at the beginning. So 5s plus 3 divided by s minus 1 into s square plus 2s plus 5 can be written as a divided by s minus 1 for the linear factor. For the quadratic factor, s square plus 2s plus 5, so you can write as bs plus c divided by s square plus 2s plus 5. So now find the LCM. So LCM is s minus 1 into s square plus 2s plus 5. Now we equate, then what do you get? A into a divided by s minus 1 on alone there, but here s minus 1 into s square plus 5, 2s plus 5. So multiply this factor, s square plus 2s plus 5 plus bs plus c divided by this factor is there, so this factor is missing. Now multiply that one, s minus 1. Now equate these two fractions. Here denominators are equal, so numerator must be equal. That means a into s square plus 2s plus divided plus 5 plus bs plus c into s minus 1 equal to 5s plus 3. Here also, either you can equate the coefficients or substitute the values for s, then you get the values of a, b, c. First, if you put s equal to 1, put s equal to 1, then this factor will be 0. So the second term will be vanished. So you get the value of a. So what you may get, if you put s equal to 1 here, so 1 plus 2 plus 5, 8a equal to, here also if you put s equal to 1, then 5 plus 3 8, so 8, so which is implies a equal to 1. Similarly, put s equal to 0, then what you may get, if you put s equal to 0, then you get a equation. Okay, so first substitute s equal to 0, then 5a plus, what about here, if you put s equal to 0, then you get c into 0 minus 1, so that is minus c. Minus c equal to, if you put s equal to 0 here, then what you may get 3. And now you know the value of a equal to 1. So if you put a equal to 1 here, then you get 5 minus 3 equal to c, that is c equal to 2. Similarly, now put any arbitrary value for s, then you get the value of b. If you put s equal to minus 1, so if you put s equal to minus 1 here, then what you may get, a equal to a into minus 1 the whole square is 1, 1 minus 2, 1 minus 2 plus 5 plus p into minus 1 plus c into minus 1 equal to minus 5 plus 3. Okay, now simplify this equation. So a into 1 minus 2 plus 5, 4 plus and the a value also, you substitute a value also, then plus minus b plus c is 2 into minus 2 equal to minus 5 plus 3 is minus 2. So now simplify, like um, so minus b. Okay, simplify this equation. Minus b plus 2 equal to minus 2 minus 4. This 4 go to that side, minus 4 divided by this minus 2. That is minus 6 divided by minus 2. It is 3. So uh, b equal to 2 minus 3, which is minus 1. So substitute ABC value in this equation. So what do you make it? So which is equal to A is 1. So 1 divided by S minus 1 plus B is minus 1. Minus 1 S. So minus S plus C is 2. So 2 divided by S square plus 2S plus 5. Now we want to find L inverse of 5s plus 3 divided by s minus 1 into s square plus 2s plus 5. So which is equal to L inverse of 1 by s minus 1 minus L inverse of s minus 2 divided by s square plus 2s plus 5. Now which is equal to L inverse of 1 by s minus 1, right, as it is. Here we are going to use shifting property, first shifting property. So for that you first make it as completing square. That is the denominator should be make it as completing square. Then what do you make it? So L inverse of s minus 2 divided by s plus 1 the whole square. So s plus 1 the whole square is what? S square plus 2s plus 1. But here plus 5 is there. So plus 4 should be added. What is first shifting property? It says that L of f of t is capital F of s, then L of e power minus at f of t is capital F of s plus a. Similarly, L inverse of, if you apply L inverse on both sides, then L inverse of f of s plus a is e power a minus at into f of s, that is e power minus at L of f of t. Okay, L inverse of um, f of s. So what we make it here? L inverse of 1 by s minus 1 minus L inverse of, so you can make the numerator as s plus 1 minus 3 divided by s plus 1 the whole square plus 4. So what do you make it? L inverse of 1 by s minus 1 minus, again using linearity property, you make it L inverse of s plus 1 divided by s plus 1 the whole square plus 4 plus 3 L inverse of 1 by s plus 1 the whole square plus 4. Okay, now we use the linearity property, I mean first shifting property. So for the second and third term, so what do you make it? L inverse of 1 by s minus 1 minus, so L of yeah, L inverse of f of s plus a is there, then e power minus at is multiplied L inverse of the remaining function. So here, in the place of s plus a, here s plus 1 is there, so a equal to 1. So e power minus t, okay, the L inverse of 1 by, sorry, s by s square plus 2 square plus 3 L inverse of, so here also, uh, if you apply first shifting property, so e power minus t L inverse of 1 by s square plus 2 square, 4 can be written as 2 square. So now, um, by the basic formulas, that is, L of sin at is a by s square plus a square. So from this, L inverse of a by s square plus a square is sin 80. Similarly, L of cos 80 is s by s square plus a square. So apply these two formulas, then what do you get? And L of L of e power at is 1 by s minus a. So here 1 by s minus 1 is there. So a is 1. So e power t minus e power minus t. Here s by s square plus a square. So that is cos 80. So cos 2t plus 3 e power minus t. Here L inverse of 1 by s square plus a square is there. So that is 3 by 2. Okay, because so here 2 is not there, so multiply and divide by 2, then you get, if you multiply in 2 and divide by 2 here, then you get 3 by 2. Okay, e power minus t, then L inverse of a by s square plus a square, so that is sin 2t. That's all. So this is the required inverse Laplace transform. Similarly, you can practice this problem, that is L inverse of 4s plus 5 divided by s minus 1 the whole square into s plus 2. For that, the answer is 1 by 3 e power t plus 3 e power t minus 1 by 3 e power minus 2t. Okay, as we discussed earlier, this can be do like 4s plus 5 by s minus 1 the whole square into s plus 2 can be splitted like a by, for s minus 1 the whole square without any power, plus b by s minus 1 the whole square, and plus c by, for the linear factor, s plus 2. So then, if you proceed like previous problems, means find the values of a, b, c, then apply the inverse Laplace transform, then you get the solution. This one. Okay, for this problem, this is the answer. You can verify it. Thank you.